Hello everyone, welcome to Basic Electronics Tutorials. In this video, I am going to take up the third numerical on Zener Diode voltage regulator. Let me read out the question first. A Zener Diode has a breakdown voltage of 10 volts. It is supplied from a voltage source varying between 20 volt to 40 volt in series with a resistance of 900 ohms. Using an ideal Zener model, obtain the minimum and maximum values of Zener currents and load currents. Let me start the solution by writing down the circuit for the given configuration. Okay, so as you can see here, you have an input voltage source that varies between 20 volt to 40 volt. The value of the series resistance is 900 ohms. We have a Zener diode which is told to be already on. The value of the load resistance is not specified here, however, we do not require it for this numerical. Please note the diode what is given here is told to be an ideal Zener diode. So, the value of its forward resistance is 0 and the value of the minimum current flowing across it will also be 0. Please note that point. Let us now list down the given values. We are told the Zener diode breakdown voltage is 10 volt. The input supply voltage range is 20 volt to 40 volt. And the series resistance value is 900 ohms. Okay, let us now start finding the load and Zener currents. To find the Zener diode current, let us apply KVL to the input loop consisting of the input supply, series resistance Rs and the Zener diode. So, the equation would be V input minus of Vz minus of I into Rs equal to 0. Please note I here is the current across the series resistance Rs. Let me rewrite this equation for V in. So, V in would be equal to Vz plus I into Rs. Let me call this as equation 1. Please note the input current I is split into Iz and IL. So, I can write it as I equal to Iz plus IL. Let me call this as equation 2. Since we are asked to find the currents across the Zener diode, let me now rewrite equation 1 for I. So, it would be I equal to V in minus of Vz divided by Rs. I will call this as equation 3. Please note the value of V in is given. It ranges from 20 to 40 volt. The value of Vz is given and it is equal to 10 volt. The value of Rs is also given, which is 900 ohms. So, now I will substitute V in as V in minimum, which is 20 volt, and thereby I will obtain the I minimum value. In a similar fashion, by substituting V in as V in maximum, which is equal to 40 volt, I will obtain the I maximum value. So, I minimum is equal to V in minimum minus of Vz divided by Rs. The value of V in minimum is 20 volt, value of Vz is 10 volt, the value of Rs is 900 ohms. So, the value of I minimum is equal to 11 milliamperes. Let us now substitute V in as V in maximum into equation 3 and find the I maximum. So, the equation for I maximum would be I max is equal to V in max minus of Vz divided by Rs. V in maximum is 40 volt, Vz is 10, Rs is 900. So the value of I maximum would be 33.33 milliamps. We will use these I minimum and I maximum values to find the Zener current values by substituting them into equation 2. Anyhow, I will do that later. First, let us find the value of IZ minimum, which is the Zener minimum current. Please note, we are told the Zener diode is an ideal diode. Therefore, the minimum amount of current that flows across it when it is conducting should be 0. So, the value of IZ minimum is equal to 0. That is, the value of IZ minimum is equal to 0 amperes. Let us now find the IZ maximum. For that, you need to understand that the input current I is split into IZ and IL. So, when the value of IZ is maximum, the value of IL should be minimum, and vice versa. That is, when the value of IL is maximum, the value of IZ should be minimum. Now, we already have found the value of IZ minimum, which is 0. So, the value of IL maximum will simply be equal to the value of I itself. Let us now prove that. So now I will rewrite equation 2, but now I will substitute I as I maximum and IZ as IZ minimum. So equation 2 becomes I maximum equal to IZ minimum plus IL maximum. The value of I maximum we just computed and is equal to 33.33 milli. The value of IZ minimum is 0 because we have assumed the diode is ideal, and the value of IL max is what we are trying to find out. So, the value of IL maximum is equal to the value of I maximum, which is 33.33 milliamperes. Let us now try to find the maximum value of the Zener current. The Zener current will reach its maximum value when the load is disconnected from the circuit. In simple words, when the load current is 0. So, I will write here as Zener current will reach its ideal maximum level when no load is connected. That is, IL minimum is equal to 0. Please note, this means that the value of the load current minimum would be 0 amperes. So, let us now substitute these values into equation 2 and find the value of IZ maximum. So, the equation 2 would be I maximum, which is the maximum current, equal to IZ maximum plus IL minimum. The value of I maximum is 33.33 milliamps. The value of IZ maximum is what we are finding, and the value of IL minimum is 0. So, the value of IZ maximum is equal to 33.33 milliamperes. Right. With that, we have now calculated all the currents of the circuit we were asked to find. Let us now summarize and write them down here. The value of Zener diode current minimum is equal to 0 because the diode is said to be ideal, and the value of Zener diode current maximum is equal to 33.33 milliamperes. Coming to the load current values, we found the value of IL minimum is equal to 0 and the value of IL maximum is equal to 33.33 milliamperes. You must note, these values are true only when the diode is assumed to be ideal. Well, with that, we have come to the end of this video. If you found this video to be informative, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.